here is shown. Question number 2. Show that the relation R in the set R of real number defined as R A comma B such that A less than equal to B square is neither reflexive nor symmetric nor transitive. You see here A element from first set and the B element from the second set, and the relation is defined on R to R, means the same set R to R. So here all the elements are real, here are also all the elements are real. Now condition is that for reflection the both element must be same. So we have chosen the suppose the element here 1 by 2 comma 1 by 2. Okay. See here both are element belong in the real set, but this type of the set is not exist here. Okay. See one because the condition is that 1 by 2 it must be greater than 1 by 2 square, means if you find its square 1 by 2, what you will get 1 by 4, which is less than 1 by 2, which is less than 1 by 2. So this condition is not followed here. That's why this is not a reflexive set. Now why I have chosen here 1 by 2? If I choose here 1 1, then it follows equal. Suppose I choose here 2 2, 2 2, here 2, then 2 2 is 4. Again it follows because it is small. But for this fractional value, this condition is not valid. Okay, but the element both are belong in the real set. That's why this we have chosen here 1 by 2 and 1 by 2. Okay. Now we are moving on the next question. Not on the next question. The remaining part is left that we have to discuss. We have done that R is not reflection. Now 1 by 4 is belongs to R. Okay, which is less than 4 square of 4. Okay, but when you change its position, means for symmetric 1 by A comma B, B comma A must be now. So its value change. Then what you will get here 4 comma 1. 4 comma 1. R is not symmetric here. Why? Because this its square is not less than 4. Okay. So you write here 4 is not less than square of 1. That's why R is not symmetric. Now 3 comma 2 belongs to R, 2 comma 1.5 is also belongs to R because these all are real numbers. Now you see here it's a square, this is less than, it's a square, this is also less than. We are write down the set according to condition, but now you see for transitive these elements you remove, so what is left 3 comma 1.5. If you find the square of 1.5, you will get this square is less than square of 3. That's why this is also not a transitive. Okay. Hence, R is neither reflexive nor symmetric nor transitive. Now, question number 3. Check whether the relation R is defined in the set this as A comma B, B equal to A plus 1 is reflexive, symmetric, and transitive. For reflection, both elements must be exist here. Okay. Suppose I have chosen here 1, then the B element is 2. Okay. You write down the set means relation. So when we write its relation, put in place of A equals to 1, 2, 3, 5, 6 and so on. Okay. But we can't here put 6. Why? Because when you put here 6 then you will get B7. But the relation is defined on R. Means R to R means 1 to 6, 1 to 6. We can't get 7 there any element. Okay. So you don't write here 7. Okay, 6 comma 7 you don't write here. This is a key point you have to understand. Here we don't need to write here 6 comma 7. Okay. Now we can find A comma A. You see here A comma A means 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6 is not belonging here. That's why this is not a reflexive. Now what's symmetric? You see 1 comma 2 is long, but 2 comma is 1 is not long. Means any element is not less than If it changing its position, you will not get any element which is less than one other element. Okay, see here 1 comma 2, it means 2 comma 1. You see here is not belong. That's why this is not also symmetric. Now we are talking about for transitivity. 1 comma 2, 2 comma 3. 2 to cancel. What is left? 1 comma 3. You see here 1 comma 3 is belong? No. So R is not a transitive. So this side, if you define under the relation R according to this condition. So this is not neither reflection, not symmetric, not transitive. Now see here next. So that the relation R in R means R to R defined as that this is reflexive, transitive but not symmetric. This relation is defined on R to R. Okay. See, we have chosen the support for any element a comma a. If you choose a fractional number that is also exist here 1 comma 1 by 2 comma 1 by 2 etc. Any number you can choose. So R is reflexive here because that's one set is exist here that is also exist here. Okay, because the A is less than or equal to B. Now next, if 2 comma 4 is belong here, it means 2 is less than or equal to 4, but if you change its position means 4 comma 2 as you write, then you will not get there. Means the condition is not satisfied, hence R is not symmetric. Next, if A comma B, B comma C, it means A less than B and B less than C. It means A is also less than C. So hence A comma C is belong. Hence means R is transitive here. It means R is reflexive here, transitive, but not symmetric. Next question number 5. Check whether the relation R in R defined as A comma B is less than or equal to BQ is reflexive, symmetric, or transitive. C. Here is written less than or equal to, and there is the power is 3 carries the power, only single power. It means this is not reflexive. See, choose here 1 by 2, 1 by 2 element. So when you do its cube, what you will get? 1 by 8. 1 by 8 is not less than 1 by 8. 1 by 2 is not less than 1 by 8. Hence, this is not reflection. Now 1 comma 2 belongs to R. Okay. Now its cube is 8. So 1 is less than 8. But if you change its position, means 2 comma 1, then you find the cube of 1 is less than by 2. In this condition is not followed here. See. Okay. That's why this is not a symmetric. Now transitivity, for transitivity we can go through with the help of fractional number. Okay. See 3 comma 3 by 2. In the next number 3 comma 2 comma 6 by 5. These all numbers belongs to the real set. And 3 by 2 cube, 3 is less than by 3 by 2 cube, and 3 by 2 is also less than by 6 by 5 cube. Okay. But you see, when we eliminate this 3 by 2, then what is left? 3 by 3 comma 6 by 5. But when you find according to this condition 6 by 5 cube, you will get this is greater than, sorry, this is less than 3. But according to this condition, A element must be less than by B element. But you see here, A's element is less greater than by B element. So R is not transitive. Hence, R is neither reflexive, nor symmetric, nor transitive. Next question number 6. Show that the relation R in the set 1, comma 2, comma 3 is given by this R1, comma 2, 2, comma 1 is symmetric, but neither reflection nor transitive. You see here 1, comma 2 and its reverse 2, comma 1 also exist here. It means this is symmetric. Okay. you see here this is symmetric, but you see 1 comma 1 2 comma 2 3 comma 3 is not exist in this side, in this relation, hence this is not reflexive. Okay, so see here we have to write here. Now you see here 1 comma 2 and 2 comma 1, so this 2 you remove that, what is left 1 comma 1, 1 comma 1 must be exist in this relation, but here is not 1 comma 1, hence you say this is not transitive. Okay, means we conclude that R is symmetric but neither reflexive nor transitive. Question 7. Show that the relation R in the set A of all the books in library of a college given by R x comma y x and y have the same number of pages is an equivalence relation. You see, if it is an equivalence relation, for equivalence relation, the relation must be reflexive and symmetric and transitive. If all these three conditions are followed, then you see the relation is equivalence relation. Now, you see here R equal to x comma y, x and y have the same number of rows. So if we choose if x comma x is also belongs to R, and the x both are the same, it means they are also having the same number of pages. It means this relation is exists here. So R is symmetric here. Sorry, reflection. Now x comma y means x and y have the same number of pages according to this condition. Now y comma x also have the same number of pages because we have to change the position only. It is not changed. So y comma x is also exist here, so R is symmetric. Now x comma y is belongs to R, y comma z is belongs to R. It means x or y having the equal number of pages y and z. Here y and x both are having, suppose this 6. So here it's y is also 6, then z is also 6. It means x and z is 6. It means x and z also having the same number of pages. So x and z is also belongs to us. So this relation is transitive. If this relation is reflexive, symmetric and transitive, then you say R is equivalence relation. Question number 8. Show that in the relation R in the set A this list is given by A minus B mod is even is an equivalence relation, so that the all element 1 3 5 is related to each other and all the elements related to each other, but no element of 1 3 5 is related to any other element of 2 comma. Now see here A equals to this and R equals to this. If we choose the A1 element, it means A element. If A mod A is to choose which is also even. So R is reflection. Now A comma B belongs to R. It means mod A minus B is even. Now we have taken out the minus common, so you write here B minus A. Here you write here B minus A. This is a mistake. So if you write here B minus A and the minus becomes positive because the modulus sign automatically changes the negative value into positive. So B minus A. It means B minus A is also even. So B comma A also belongs to R. Hence R is symmetric. Next, for transitivity, if A comma B belongs to R and B comma C belongs to R, it means A minus B is even and B minus C is even. It means if we write A minus C, so A minus C we can write A minus B plus B minus C. So A minus B is even and B minus C is even. Even plus even we will get even. So A minus C is also even. That's why we say here A minus C is even. Hence A comma C belongs to R. R is transitive. Hence R is an equivalence relation. Now, all elements of the set 1, 2, 3 are related to each other. All the elements of the This subset are odd. Thus, the modulus of the difference between any two elements will be even. Similarly, if the 2, 4 are related to each other, the elements of this subset are even. सेम ये प्रोसेस फॉलो करूंगा अपने से भी डायरेक्टली प्रूव कर दूंगा इवन ठीक so also no element of the subset 1 comma 3 can be related to any element of 2 comma 4 as all element of 1 comma 3 are odd all element of 2 comma 4 are even thus modulus of the difference between the two elements from each of these two subsets will not be even. Suppose one chosen from here, two chosen from here, and then you find modulus, you will not get even. So that's thing we have written. Okay. So that each relation R in the set A X belongs to Z means real set here, and X belongs to Z means an integer. Okay. And the value 0 to 12 given by R A comma B A minus B is a multiple of 4. Okay. So you see in the set goes through 0 to 12. Okay. For 0 to 12, A minus B is a multiple of 4. So you should have if the same element 1 1 0 0. You see here 1 minus 1 means A minus A modulus you will get 0 which is also multiple of 4. So R is reflexive. Next, if R is reflexive, A comma B belongs to R, then A minus B is multiple of 4, then you take out the minus common here. Then it is left to B minus A. So B minus A is also multiple of 4. So B comma A belongs to R. So R is symmetric. Next, if A comma B and B comma C belongs to R, it means A minus B is multiple of 4, B minus C is also multiple of 4. Suppose this is 4 to 0, this is 4 3 are 12. So 12 hence A minus C is also multiple of 4. Hence R is transitive. Hence R is an equivalence relation. Set of all elements that are related to 1. 1 5 9. 1 minus 1 0. 1 minus 5 you will get 4 which is also multiple of 4. 1 minus 9 8 which is also multiple of C here. Now R A comma B A equal to B. For any element A belongs to A, we have A comma A belongs to R. Since A equal to A, R is reflexive. Now let A comma B belongs to R A equal to B. So you can say B comma A also belongs to R. Hence R is symmetric. Let A comma B belongs to R and B comma C belongs to R. You can say A equal to C. Hence A comma C is belongs to R. So R is transitive. Hence R is equivalence relation. One element from the set A which is equal to only 1. So the set 1 is related to is 1. There is only one element. Question number 10. Give an example of a relation which is symmetric but neither reflexive nor transitive. For symmetric, we have chosen here 5, 6, 7. The set relation R on R 5, 6, 6, 5 we have chosen. For symmetric, there inverse also exists here means 5, 6 to 6, 5 also exists. So this is symmetric exists here. For reflexive 5, 5, 6, 6, 7, 7 is not belongs to R. and this is not reflexive. For similarity transitivity, 5 6 comma 6 is removed, 5 comma 5 is not exist here. That way it is also not a transitive. Now next, transitive but neither reflexive nor symmetric. Not symmetric we have to introduce here inequality like greater than or less than symbol. So we have introduced here less than symbol, a less than b. Okay, set r in r. Now you see here a comma a. No element a comma a exists here. Okay. But a is belongs to r and this a also belongs to this r. This inequality, this type is not existing. A comma a belongs to r. Since a cannot be strictly less than r itself, in fact a equal to a. Hence, this is not reflexive. Next, 1 comma 2 belongs to r. You see here 1 is less than 2. When you change its position 2 comma 1. So you see here this 2 is not less than 1. So r is not symmetric. Similarly for transitivity, a comma b, b comma c. A is less than b, b is less than c. Okay. So you see here a is less than c. So r is transitive. Okay. So r is transitive but not reflexive nor symmetric. Next relation we have to prove that find the such that side R is reflexive symmetric but not transitive. Okay. See here for reflexive all the element existing means 4 comma 4 6 comma 6 8 comma 8. Okay. But for symmetric 4 comma 6 6 comma 4 also exist. 6 comma 8 8 comma 6 also exist. But for transitivity, you see 4 comma 6 6 comma 4 4 exists. Okay. But you check 4 comma 6 6 comma 8 4 comma 8 is not exist here, so that's why this is not here transitive. So this question is reflexive. For reflexive any condition is followed, you say this is reflexive. But for transitive any condition is violated, it means you immediately say that the relation is not transitive. Next, fourth we have to find the relation R such that reflexive transitive but not symmetric. Means not symmetric is A comma B, B comma A is not now. We have to introduce immediately for symmetric inequality. Okay, not symmetric. We have to introduce inequality. So we have to introduce an inequality sign and the relation is chosen that like that A cube is greater than B cube. Okay, now see here A comma A is belongs to R, so R is reflection. For R is not symmetric, you see here 2 comma 1 belongs to R and 1 comma 2 is not belongs to R. Hence R is not symmetric. Next, A comma B. So A is greater than B, B is greater than or equal to C. You see here A cube always greater than or equal to C. So R A comma C also belongs to R, hence R is transitive. Hence the relation R is reflexive transitive but not symmetric. Next, A equal to minus 5 comma 6 define a relation R on A as minus 5 comma 6 minus this. We have to find here the relation such that R is symmetric transitive but not reflexive. For reflexive, the same element does not exist, means minus 5 comma 5 minus 6 comma 6 is not existing. So we have introduced here one element minus 5 comma 5 but minus 6 comma 6 is not introduced. Okay, to see here this element is here symmetric because minus 5 comma 6 minus 6 comma 5 is also exist here. For transitivity minus 6 comma 6 is cancelled to minus 5 comma 5 and it's minus 5 comma 5 also exists. So this is transitive and symmetric also but not reflexive. Okay. Hence R is symmetric and transitive but not reflexive. Question 11. Show that the relation R in R the set A of a points in a plane given by R equal to a p comma q distance of the point P from the origin is the same as the distance of the point Q from the origin is an equivalence relation. Further show that the set of all the points related to point P is not equal to 0, 0 in the circle passing through the P with origin as the center. So this is a set P comma Q. P and Q the distance P from the origin is the same as the distance point Q from the origin means P of Q point. Suppose this is the origin here. If this is origin, suppose from this origin P point, from this origin Q point, both are having the same distance. Okay. So if I choose here P comma P always having the same distance. So this also exists here. It means this is reflexive. Similarly, for if P comma Q are having the same distance, it means Q comma P is also having the same distance. So R is symmetric. Now, if we have chosen the P comma Q, Q comma S, means P comma Q having the same distance Q comma S. Suppose P comma Q 4 4 to Q comma S, this 4 and this is also having the 4 distance. It means P and S also on the same distance. So P and also belongs to R. So R is transitive. Now the relation is reflexive, symmetric, transitive. So this relation is equivalence relation. Now the set of all the points P is not equal to 0 will be those points whose distance from the origin is the same as the distance of the point P from the origin. Suppose OP equals to K, then the set of all the points P is at the distance of K from the origin. Hence, the set of points form a circle. Means suppose this is a fixed P is up here, P equals to K this distance, and you rotate here, so you will get a circle. So this the relation shows here circle. Next, show that the relation R is defined in the set A of all the triangles R in T1, T2. T1 is similar to T2 is equivalence relation. Consider these right angle triangle T1 with the side this, T2 is this, and T3 is this. Whose triangles among T1, T2, T3 are related? Which triangle among T1, T2, T3 are related? If T1 and T2 are similar, suppose T1, T1 we have chosen. So T1, T1 means triangle similar itself always. So R is reflexive. If T1, T2, it is given here T1 and T2 are similar, so T2 and T1 is also similar. Okay, hence R is symmetric. For T1 and comma T2, T2 comma T1, it means T1 similar to T2, T2 similar to T3. It means T1 and T3 are also similar. So T1 comma T3 is belongs to R, so R is transitive. Hence R is an equivalence relation. Okay, but one thing you observe here: 3 to the 6, 4 to the 8, 5 to the 10 means here the ratio is constant. 3 by 4, 4 by 6, 5 by 10 equals to 1 by 2. It means these sides of triangle T1, these sides of triangle T3. It means T1 is related to T3. Hence the triangle T1 is similar to triangle T3. Question 13. Show that the relation R is defined in the set A of all the polygons as R equal to P1, P2. P1 and P2 have the same number of sides is an equivalence relation which is the set of all the elements in A related to the right angle triangle. and P2 are having the same number on the sides. So P1, same polygon have the same number of sides itself, so it is a reflexive. If P1 and P2 have the same number of sides, so P2 and P1 also have the same number of sides, so P2 and P1 is also belongs to R. In this relation is all. Now P1, P2, P2, P3 belongs to R. So P1 and P2 have the same number of sides. Also P2, P3. This means P1, P3 have the same number of sides. So R is transitive. Hence A is related to the right angle triangle with the side 3, 4, 5. Polygons which are having the three sides, since T is a polygon with three sides. Hence the set of all the elements A is related to the triangle T is the set of all the triangles. Let L be the set of all the lines x, y plane. R is the relation in L defined as R L1, L1 is parallel to L2, so that R is an equivalence relation. Find the set of all the related to the line by equals to 2x plus 4. Okay. Now suppose we have chosen the L1, L1. So L1 always parallel to L2. Similarly, if L1, so L1 is also parallel to itself. So this is reflexive now L1, L2. So L2, L1 is also parallel. So R is symmetric. Now L1 parallel to L2, L2 parallel to L3. It means L1, L3 also parallel. So you see it is a transit. So this is equivalence relation now. Set of all the lines related to this by equal to x plus 4 is the set of all the lines that are parallel to a set line by equal to 2x plus 4. Here m equals to 2. It is known that the parallel lines have the same slope, so the lines parallel to the given lines is of the form y equals to 2x plus c, where c belongs to R, where c belongs to R. Hence, the set of all the lines related to the given line is given by y equal to 2x plus c, where c belongs to, because we have must we follow the parallel line condition. Now, question number 15. Let R be the relation in the set this is given by this. Choose the correct answer. R is reflexive, symmetric, but not transitive. See here 1, 2, 2, 2, 4, 4, 3, 3. These all elements belong and 4, 4 is also belong. It means this relation is reflexive. So this is reflexive, this is reflexive, this is not reflexive. It means B, C answer cancelled. Okay. Now the A, B, D are three options left. We have to check it also. 1, 2. See here. 1, 4. Sorry. 1, 3, 3, 1. Okay, this is also finished. See here. This 3, 2. 3, 2 and 2, 2. 3, 2 left. Okay, 1, 2. See here 1, 2 and 2, 1. 1, 2 and it's 2, 1 is not existing. Hence, this is not symmetric. Okay. If it is not symmetric, where are this option? So this option is also cancelled, this also cancelled, now this option. So B option is right option here. Okay. See here 1, 2, 2, 1. Its reverse is not existing. That's why here only B option is right option. This is not symmetric. And all the both condition is false. Question 16. Let R be the relation in the set N given by this. Choose the correct answer. See here B is greater than 6. If B is greater than 6, it means here this number is always greater than 6. And this is set R with the relation in the set N. N is natural number. Okay. For natural number, so you see here for natural number B value never be 6.5, it means B value can be possible 7. If we put here 7, then 7 minus 2 5. So 5 comma 7 here any element is no. Now if we I put here 8, 8 minus 2 6, A value 6 and this means C option is right option. Okay. You see here B greater than 6, 3 comma 8 is not existing here. So you see here this is existing. Thank you.